That part was not covered. Like it was just about to start.
Oh, okay. Okay, it's very simple. Just wait a minute, please. So we are going to see preparation of aldehyde from hydrocarbon, right? So it's basically alkene from hydrocarbons. And we can further divide it by ozonolysis of alkene. So see what it is. It's very easy. Ozonolysis, that means you are going to react this alkene with ozone, that means O3, and then reacting it with ZnH2, and you will get an either aldehyde you will get, or you can also get ketone. So how does it work? It's very easy. You can see this is your alkene, and if you are going to react it with O3, what happens here? I'll show you. This, just remove this double bond and make a home-like structure O, O, O along the double bond. And after this, if you are going to use ZnH2, so what will happen here? It's very easy. This bond will be broken like this, and this bond O will go with ZnO, and now you can see this is CH2. That means C, H, H, and O and carbon will be now doubly bonded. That means we can call it HCHO, that is methanol. And again, you can see this is CH2O, that means H, H. Double bond O. And we can also write HCHO, and that means methanol. So by ozonolysis of ethene, 1 mole of ethene, you can call 1 mole of ethene, we will get 2 mole of methanol. Is that clear?
Sir,
Please do write it. I think you have studied this in class 11. Let me know when you are done with this. Are you done with this?
Yes, sir.
Alan, Mirage. So I just started preparation of aldehyde. And see, we are going to prepare aldehyde from hydrocarbons, in which we are specifically going to prepare aldehydes from this ozonolysis of alkene. And we can also prepare ketones from ozonolysis of alkene. So this is the first example. If you have an alkene, that means double bonded hydrocarbon, you are going to remove this double bond and make a home-like structure, and then break this bond in the presence of Z and H2O. Then this O will be eliminated. Now you will have left with CH2O. That means HCHO, 2 moles of methanol you will get. So I'm going to change the slide. If anyone writing, just take a screenshot. Please let me know. Alan?
I'm done, sir.
Maraj? Okay. So I'm going to give you a question on this. Please do it and let me know the name of the product. If you are going to do ozonolysis of this propene or prop1A, then you will get a intermediate type of structure, and then Zn in the presence of H2. Let me know the name of the product.
A is methanol and ethanol.
No, that will be basically here, methanol and ethanol. It will be like, just like intermediate, I told you. The O3 will, I'm going to write this structure, you can see CH3, single bond CH, and then don't show the double bond. It will be like this, and home like a structure like this. And after this, you are going to pass it through ZnH2. Now you can see what you have in the left hand side, CH3 CHO. So it will be basically CH3 CHO. Or if you want to write
Upper O.
double bond O, that's very good. And this is CH2O, or you can write either HCHO. HCHO. That is basically HC double bond OH. So your answer is right, but this is not it. You can see this. So it is propanol, sorry, ethanol. 2 carbons are there, so it's ethanol, and this is methanol. Right, Zeb, Alan, and Mehraj? Please do let me know when you are done with this. Alan and Mehraj.
Yes, I'm done.
No. Moving to the next. If I'm going to give you a question like this, you're going to do the ozonolysis of this alkene to CH3, C, and then there is CH3. and then double bond, and then CH2, and then CH3. In the first step, you are going to do O3, and in the second step, Zn/H2. Please do this.
So we'll get 2 ethanol.
You will get 2 ethanol is the wrong answer. Please do it as I explained, stepwise. Alan and Mehraj, I want answers from you too also.
So propanol and ethanol.
See, ethanol is one of the product, that's good, but propanol, are you saying propanol or propanol?
Propanol.
Propanol or ethanol, right?
Yes, sir.
But the prop is not the right answer. So I'm going to show you the stepwise. Again, you are going to write the structure in the same way as its reactant, but just don't show this and move to this CH2. And can I shift this CH3 little bit to like this CH3 and then CH3? Is there any problem in this?
No, sir.
Now, I'm going to make a home-like structure like this, and then I'm going to break this. Oh, wait a minute. I just forgot to write CH3 here. Now, see, what will happen? Just break this bond and this bond. In the presence of ZnH2O, what will you get? It's very easy to understand. You will get CH3, C, CH3, and C is connected with O. So this is CH3, C, and there is O, and there is C. And as you know that this carbon is not satisfied, so it will make double bond with oxygen. And the next one is CH3, CH2O. That means CH3, CH. Oh, wait a minute. Okay. Oh, there is a slightly mistake. That mistake is basically this carbon is making 5 bonds. That is not possible. I have to remove one of the hydrogens from here. Are you getting my point?
Yes,
So it
sir.
will be CH3, CH. So that was by mistake. Sorry. Now you can see. Can you call it propanol? Zab, Alan, and Mehraj. This is propanol now. It is basically what? It is basically a ketone, right? And this is your aldehyde that you called it correctly, ethanol. So basically from ozonolysis of alcohol, we can prepare ketone too. That depends upon the reactant. Is that clear, Alan? Mehraj?
Yes, sir.
Yes, sir.
Please do write it. I am going to give you one more question. Then I will reverse the question. Right now, what we are doing is ozonolysis of alkene. And after this type of question, I'm going to give you questions. Basically, I will give you the product you need to predict the reactants. It's very interesting. Everyone done with this? Miraz, Zed, Alan. Can I change the slide? Zed?
Yes, sir.
No. Alan, you are also done, right?
Yes, sir.
Okay. This is the question I wanted to give. You're going to do the ozonolysis in the first place, and you will get an intermediate type of structure, then Zn followed by ZnH2. Please do this. Are you done with this?
The one product is propanol.
And another is
There is but something.
did you say propanol?
Yes, sir. Propanol.
And the second is
Something like butane.
butane.
To all.
Very good. Everyone got this answer, or Alan?
Yes, I got propanol.
You got the right answer.
Yes, sir. The half part. I didn't get the second part probably, sir.
Okay, please do the second part also. What about you, Maharaj?
Sir, understood, sir.
You have understood. Please do it if you can. See, I'm going to give you a question. No, not question. I'm going to explain it. So this is basically CH3. This is C. This is CH3, and then double bond. So after this is basically CH2, CH, and this is also CH3. So this is O, this is O, this is O. You are going to make a home and then break a home like this. So you can see on the left hand side, you can see this is basically CH3, then this C, then CH3, and then C is connected with O, so it will be double bond. Now the next you can see this is CH3 and then C, and this C is connected with this CH2, and this CH2 is connected with CH3, and C is also connected with oxygen, so it will be double bond. So the name will be propanone, butane 2-on, or you can write propane 2-on also. Is that clear, everyone? Zaid, Alan, Meraz.
Yes, sir.
Okay. Now I'm moving to another type of question of this. This is the last type of question. Last type. This is an alkene. There is an alkene A on ozonolysis. On ozonolysis gives a mixture of ethanol and pentane 3. Write the IUPAC. Write the structure first and IUPAC, name of alkene. Please do let me know if you are unable to solve this question. I'm here to help you. Zed, are you done with this?
No, sir.
So see, whenever this type of question will come, you are going to write the structure of product first. So there is ethanol and pentane 3 on. So what will be the structure of ethanol? That is CH3CHO and then pentane 3 on CH3 CH2 and then C double bond O and then CH3 CH2 CH3. This is the structure of pentane 3 on. Yes or no?
Yes, sir.
And this is the structure of ethanol and I'm going to write it like can I write it like this: CH3 CH double bond O. Now what you need to do, it's very simple, it's just like a trick. You can see I'm going to write this CH3 C double bond O and H, and I'm going to write this as C double bond O first, and then there is CH2 and then there is CH3, and this carbon is also associated with CH2 CH3. Can I write this as this and this as this? All of you.
Yes, sir.
Yes.
Now what you need to do, it's very simple. Just remove this O2. Just remove this O2 and combine this CC with the double bond. You will get your product. You will get your product, as you can see that it will be basically CH3, and then this C is associated with H. There will be double bond. Just remove this O2 and it will be directly connected with this carbon C, and then this C is connected with CH2 CH3, and then this carbon is also associated with CH2 CH3. So this is the alkene that we did as analysis of this alkene, and we got pentane 3 on as well as ethanol. So what will be the name structure of this is this 1 2 3 and then 4 and then 5. So name is basically 3 methyl pent 2 in. Is that clear? So what you need to do, just write the structure and double bond C double bond O C double bond O together and remove this O2. You will go, get uh, the required alkene. Yeah.
So it'll be 3 ethyl, right?
What you just said?
So then the name is supposed to
Yes.
be 3 ethyl or 3 methyl.
3 ethyl. Sorry, I just wrote it wrong. It's ethyl na. This is 1 meth and then eth. So it is 3 ethyl, not methyl. Thank you, Alan. Please do let me know when you are done with this. Done, everyone?
Yes, sir.
Very good. Now I'm going to again give you on this a question. An alkene A on ozonolysis gives 2 moles of ethanol. Write the structure and IUPAC name of it. Please do it.
Sir, two butene.
2-butene. Everyone got the answer 2-butene? Butane or 2-butene?
Yeah.
Okay, please let me know. Maharaj. See, I'm going to explain. 2 moles of ethanol, that means you have 2 ethanol, CH3, CHO. You got the 2 product, CH3, CHO. And I'm going to write this CH3 as this double bond O and this double bond O, C, and then H, and then CH3. So this will be eliminated and you will get CH3, CH, double bond, CH, and then CH. So if you are going to name it 1, 2, 3, 4, so it will be But2E. This is the required alkene name and structure you can see. Are you done with this? Zab, Alan, Mehraj.
Yes.
Zab, what is said?
Yes.
Now we are moving to the next type of preparation, that is basically from acyl chloride, or we also call it acid chloride. Acid chloride. So this is a name reaction. Basically here the acyl chloride, I'm going to write a point about it, then I will make a reaction from this sentence. So basically acyl chloride or acid chloride is hydrogenated, or you can call it hydrogenation of acyl chloride over catalyst or in the presence of catalyst. palladium, on barium sulfate, barium, BaSO4, and you can get an aldehyde, and this reaction is known as Rosenmund reaction. Rosenmund reduction. Basically, if you are going to add hydrogen, that is reduction, so we call it Rosenmund reduction. I will explain the reaction. First, you are going to write it. So I'm going to explain it. First, you are going to concentrate here. You have an acyl chloride. This is your benzene, and acyl chloride, that means COCl. COCl. What is acyl chloride? This is a functional group for state chloride. Acyl halide we also call it. And if you are going to react this, or if you are going to do hydrogenation of this acid chloride, hydrogenation, that means addition of hydrogen in the presence of catalyst palladium over BaSO4, barium sulfate, then there will be reduction that will produce aldehyde. So you can see what will happen here. If you are going to add hydrogen, already all the elements are satisfied with their valence. Basically, that means all the elements are fully satisfied, octets complete. So in order to add something new, you need to break the old bond. So I'm going to break one of the bond between carbon and oxygen, and basically, oh wait a minute, not carbon and oxygen. I'm going to break the bond between chlorine and carbon, and hydrogen will be added with chlorine and hydrogen will be added with carbon. Now you will get your product as you can see. This will be C double bond O and then H, and HCl will be the what we call it byproduct, and this is benzaldehyde. And reduction takes place. The name reaction is basically what this Rosenmund reduction. Let me know when you are done with this. Are you done with this?
Yes, sir.
Zach,
Yes, sir. Done.
Meraz,
Yes, sir. Done.
thank you. Now the next type of chemical preparation of aldehyde is basically from nitriles and esters. First, we are going to deal with this nitriles. So basically, you can see this is also a name reaction, and basically, it is also a reduction process. Nitriles are reduced. That means addition of hydrogen will take place to corresponding imine with stannous chloride, SnCl2, that we call it stannous chloride. In the presence of hydrochloric acid, which on hydrolysis give corresponding aldehyde. Which on hydrolysis gives corresponding aldehyde. And this reaction is known as Stephen reaction. This reaction is known as Stephen reaction. Sorry.
Screen not visible.
This reaction is known as Stephen reaction. Wait a minute. What? You are screen sharing, that's okay. Can you see the screen? Let me know when you are done with this. Then I will explain the reaction. Everyone done with this?
Yes, sir.
So I'm going to start the reaction. Please focus here. You have a nitrile that we also call it cyanide. Awesome. You are going to reduce it basically in the presence of stannous chloride and hydrochloric acid. Then you will get an amine, that means RCH double bond NH. And after hydrolysis of this, I will explain the mechanism also, the trick to get it solved. After hydrolysis H3O positive, you will get RCH. Now, how did we get this? Now, it's very simple. You know that the bond between C and N will be triple. So, if you are going to react this with stannous chloride in the presence of HCl, it will be reduced. This nitriles will be reduced. You can see how it will be reduced. One of the bond between carbon and nitrogen will be broken and hydrogen will be added to nitrogen as well as carbon. Then you will get RCH double bond N. Is that clear, everyone? Is that clear?
Sir, can you repeat once?
See, Z, this is triply bonded. So in order to reduce it, you are going to add hydrogen to this nitriles. And in order to add, all the carbons and nitrogen are satisfied with their bonds. So in order to add something new, you need to break the old bond. So one of the bond between carbon and nitrogen will be broken. Now carbon will be like this and nitrogen like this. So now they can make one more bond. So this hydrogen will be added to nitrogen and carbon as well. So this is your imine. Is that clear?
Yes, sir.
Now I have a question. Can you tell me which one is more electronegative, carbon or nitrogen? Alan, Mehraj, which one is more electronegative, carbon or nitrogen? Zach, always remember that this fluorine is the first most electronegative element, then oxygen, then nitrogen. Nitrogen is more electronegative element, that's why there will be negative charge and there will be positive charge. Can I put this charge like this? Zach?
Yes.
Now see, H2O has two parts. You know that H2O has two parts, H plus and OH minus. Yes or no? So if you are going to do hydrolysis, that means H plus and OH minus will be there. And in this way, basically, this will be after hydrolysis, you will get RCHO. This oxygen will be coming with carbon because it has negative charge, and this hydrogen will be going with NH and it will form NH3 and you will get RCH. Please write this.
So is this mechanisms important?
It's not mechanism. Basically, it's just a trick to understand the reaction, how the reaction happened. It's not exactly the mechanism. Let me know when you are done with this.